Stand on the rim of a canyon and yell, "Ho-oh! Ho-oh!" And you hear your word a second or so later. That's an example of echo. Essentially, it's the sound that's reflected.
Eyes closed!
Sound bounces off walls, floors, ceilings, and other hard objects. When these used in studios. Tape recorders were typically used to create actual echo. The studio term for this was slapback. Today, both reverb and echo can be created digitally. When used properly, they can add a live quality to the recording and help in getting a better performance.
Thanks, Mr. Audio.
For more interesting facts about
sound is a part of our everyday sensory experience. So how is sound produced, propagated and detected? A good model is the stethoscope, used to listen to the sounds of heart and lungs. But how are these sounds heard? To understand this, we need to know what reflection of sound is. When sound travels
When you stand on the rim of a canyon and yell, "Ho-oh! Ho-oh!" and you hear your word a second or so later, that's an example of echo.
through a medium, it strikes the surface of another medium and bounces back to the original medium. This phenomenon is called the reflection of sound, which obeys the laws of reflection. The first law states that the angle of incidence is equal to the angle of reflection. We can provide this by placing two tubes at certain angles on a wooden board. If a clock is placed near the end of one of the tubes, we can hear the sound waves through the second tube by adjusting it to get the sound at its maximum. We can see that the angle of incidence is equal to the angle of reflection. The second law states that the incident wave, the reflected wave and the normal at the point of incidence all lie in the same plane. Sound waves also suffer reflection from large obstacles. If we stand at a distance from a high wall and clap our hands, we can hear the same clapping sound after the dying out of the original sound. This is called an echo.
Right together. That's good.
Therefore, for an echo to be heard, the time interval is 0.1 seconds. As sound travels at a speed of 340 meters per second in air, the distance traveled by sound in 0.1 seconds is 34 meters. Therefore, to hear an echo, we need to stand at least 17 meters away from the wall.
Sit door.
Now, what happens if there are 4 enclosed walls that are less than 17 meters away? What we experience here is a reverberation that is due to multiple reflections of sound from the walls, roof and floor, which follow so closely behind the original sound that the original sound appears to be prolonged even when the source of the sound stops. We can thus say that reverberation is the multiple reflections of sound waves, whereas echo is the single reflection of sound waves. However,
did you get that big anvil strike last night?
I wasn't even out.
I got it!
excessive reverberation makes the sound indistinct, which can be a setback in auditoriums. This can be reduced by using sound-absorbing materials like ceilings made of soft and textured materials and flooring made of acoustic tiles. Certain technologies make use of the multiple reflections of sound. To name a few, we have megaphones, hearing aids, soundboards, stethoscopes, and the curved ceiling of concert halls. Now, back to our stethoscope. The stethoscope picks up multiple reflections of sound from the patient's body. This causes the flat surface of the diaphragm to vibrate. Each wave bounces or reflects off the inside walls of the rubber tube. In this way, Each wave in succession reaches the ear tips on the ends of the device and finally to the listener's eardrums, and the doctor interprets the sound he hears.
Echo method of determination of speed of sound. The echo method can be used for determining the speed of sound in air. A cannon is mounted and fired in front of a vertical cliff, which is at an appreciable distance d away from the cannon. When the cannon is fired, an observer at the same place starts a stopwatch. When he hears the echo after sound is reflected from the cliff, the stopwatch is stopped and time t is noted. Sound travels from cannon to cliff and back. Total distance travelled by sound equals 2d. Time equals t seconds. Therefore, the speed of sound equals 2d upon t meters per second.
Sonar. Sonar stands for Sound Navigation and Ranging. It is a device which uses ultrasonic waves to measure the distance, direction, and speed of underwater objects and helps mariners to investigate the nature, size, and location of the object so that potential threat to the vessel is identified and overcome. How does it work? Sonar has a transmitter and a receiver which are installed at the bottom of the ship. The ultrasonic waves transmitted by transmitter travel underwater and get reflected back from obstacles. The detector receives the signal and converts it to electric signal. A computer forms image of the obstacle and displays it on a monitor. It also calculates distance of the object using this formula. Distance is equal to speed into time upon 2. Speed is equal to speed of sound in saline water equal to 1530 meters per second. This method is called echo ranging. The sonar technique is installed in every ship to determine the depth of the sea and to locate underwater hills, valleys, submarines, icebergs, and sunken ships, etc., to avoid a disaster.
Things to remember. The property of sound to bounce back from the surface on which it falls is known as the reflection of sound. Echo is heard only if the minimum distance between the source of sound and the obstacle is 17 meters. Reverberation is multiple reflections of sound after the original sound is produced. The first law of reflection states that the angle of incidence is equal to the angle of reflection. The second law states that the incident wave, the reflected wave, and the normal at the point of incidence all lie in the same plane.